All right, we're recording. Hello, everyone. Welcome back. Welcome to the day 2 of the Forge Online Bootcamp event. Again, my name is Petr Broz, and today I'm joined here by my colleague Xiaodong. We're both Forge developer advocates. We're going to be helping you through this lesson. Now, in case some of you are joining us here for the first time today, this event is basically we're offering this event to those of you who are more comfortable getting a more guided approach to tutorials, because we already provide many different learning resources when you want to get started with Forge development. The really important one being the learnforge.autodesk.io website. And there are a couple of tutorials that you can follow on your own, but in this Forge Online Bootcamp event, we basically live code through that tutorial with you, explaining all the different aspects of the Forge development along the way. So again, this event is more for those of you who are more comfortable getting more guided approach to these tutorials. And again, every webinar of the Forge Online Bootcamp event this week is basically split into 4 sessions, where at the beginning of the session, we will always implement part of the tutorial ourselves, and then we'll give you some time to follow our steps and ask questions, right? We will be using the Zoom options that you hopefully see in your Zoom toolbar. Feel free to use the chat or the Q&A to ask your questions, and Xiaodong or myself will try and answer those in between the sessions. All right, and also all these recordings from this week are being recorded, and we will share them with you until after the event. So don't worry if you miss any specific part. You can always come back to these, and we will share them on YouTube, and we'll make sure that you all get the links to these recordings. All right, today we're at day 2, where we're going to be looking at a specific tutorial from the LearnForge website, where we're going to be building an application that will allow us to basically browse through our existing content in some of the Autodesk products built on top of the Autodesk Forge platform, because Autodesk itself is already building a couple of its own offerings built on top of our platform. If I swap over to the LearnForge website, what we're going to be looking at today is basically this tutorial called View BIM 360 and Fusion Models. So it's going to be very similar to the application we built yesterday for those of you who joined us on Monday, with the one exception where we're not going to be creating buckets and uploading files to the Forge Data Management Service. Today, instead, we will be using the Data Management Service to actually browse the content of our users and the users of our application who log in with their Autodesk credentials. All right. This is going to be the application we're going to be building. So this time we're going to need to incorporate some sort of login authentication system for our users, so that the users of our application can log in and see their own data within our custom Forge application. All right. And as for the sessions, the first session, just like yesterday, we're gonna make sure that we have all the accounts and application integrations ready, and that we have some development environment available as well. In session 2, we're going to start implementing our Node.js server and provide some basic authentication endpoints to it. In the third session, we're going to start adding logic to our server so that we can then browse through, again, our content in the third-party applications such as BIM 360, Fusion Team, or the new offering, the ACC, the Autodesk Construction Cloud. And finally, in session 4, we will tie everything together with a little bit of user interface, with a little bit of HTML, CSS, and JavaScript, where we're going to basically show the expandable tree with the content of our users, and with Forge Viewer, of course, to preview the models that they select in the tree. All right, so let's move to session 1. Again, for those of you who are joining us here again, after the Monday lesson. We're also going to need one more time a Forge account. So if you don't have one, simply head over to the Forge portal. That's the forge.autodesk.com website. And if you don't have an account here, you can simply sign up and you will get a trial Forge subscription, which is valid for 3 months, so that you can check some of the features of the platform before you maybe decide to go to a paid subscription. This time, one minor difference compared to the first tutorial we did on Monday, we will also need to set up this thing called custom integration with one of the Autodesk products built on top of the Forge platform. In my case, I'm going to be using BIM 360, but potentially, if you don't have access to BIM 360, that's fine. You will be able to browse your content on from other Autodesk products, like from A360 or Fusion Team as well. In my case, I've been going through some of my BIM 360 accounts, and I found one where I was an admin, which is going to be a requirement. I'll get to that. I'll explain that in a moment. So that's what I'm going to showcase. But again, if you don't have a BIM 360 account, or you don't have an account admin privileges, don't worry. You can still follow through the tutorials with us today. And you'll still be able to see your content from, let's say, Fusion Team. All right, and also we're going to need a Forge application, and I'm going to explain what that means on the Forge portal. And then for the development, again, this webinar is focused on Node.js. My colleague Adam is running another webinar in parallel right now that's focused on .NET. So we're gonna make sure that we have Node.js environment ready to be used before we start implementing something. And I'm also going to recommend some editor environment that you may want to use as we progress through this tutorial. Although you're not required to use this particular editor, we definitely recommend that you give it a shot. All right, demo time. Let's switch back to the Forge portal, forge.autodesk.com. First of all, again, sign in, or if you don't have an account, you can simply create a new one for free, and you'll get a Forge subscription for 3 months, a trial subscription. What I'm going to do is I'm going to sign in with my credentials. And after signing in, what you'll see is under your profile in the top right corner, you'll see that there's a section called My Apps. This is where you can manage your Forge applications. And basically what those mean, a Forge application is not really a piece of software deployed to AWS or Azure to the cloud somewhere. A Forge application is really, in its core, just a set of credentials, sort of like you can think of it as your application's username and password, that you're going to use when communicating with Forge, right? Because in order to talk to the Forge platform, you will need to authenticate yourself in some way to let Forge know who you are. For that, we're using Forge apps here. So what I'm going to do, and what I'd like to ask you to do, is to use this Create Forge App button. And I'm going to give it some name. Online Bootcamp, September 2021. I'm going to say it's a traditional app. So if you already created your app yesterday, feel free to use that one. If you haven't, you can just create a new app. I don't really think there's any limit to the number of applications you can have. And it's good to really create separate applications for, let's say, separate products that you're building with Forge, right? Because these will be basically siloed, and your data managed or owned by one Forge application will not be accessible by other applications unless you actually explicitly specify so. All right, now that we have our application, you'll see that that app will have access to some APIs. some parts of the Forge platform, but more importantly, the application will have its own client ID and client secret generated. Those are really the credentials of your app. That's the sort of like the username and password that we're going to be using when communicating with the Forge platform. And most components of the Forge platform are web services, so we're going to be making HTTP requests to these. And you can really communicate with those services from any environment that can make web requests. That can be a command line. You can make curl requests to, let's say, the data management service in Forge, or you can use third-party GUI HTTP clients like Postman or Insomnia, right? Or you can use your custom application that will make web requests to the Forge platform. In that case, when developing your own code, we also provide SDKs, Forge SDKs for different languages, so that you don't actually have to build the entire HTTP request from nothing, and you don't have to worry about every single header that is required, and query parameter and special structure of the request payload, and you don't have to worry about parsing the responses. For that, we provide the Forge SDKs that will provide a higher level of abstraction where you can basically make a request to one of the Forge services through a single method call, basically. And the method call under the hood will take care of everything else, building the request, sending it off, waiting for the response, and parsing it for you. Okay, in all of these situations, no matter where from you want to communicate with Forge, you'll always need these two credentials, the client ID and client secret. So make note of these, as we're going to need them later. Now, today, since we're going to be using this user login workflow as well, where in our application, we will ask our users to log in, we will also need this additional specific property called callback URL. This would be the URL where we want Autodesk to redirect users to after they log in successfully. So we're basically going to be building something called a three-legged workflow authentication or authentication workflow, where our app will provide a login button. And when the users click that login button, we will redirect them to the Autodesk servers, where they will be asked to log in and basically confirm that they allow this Forge application to do something. And when they click that allow button, Autodesk will need to redirect them back to us to some address, right? And that is the callback URL. So later on, we will edit this application and modify the callback URL to make sure that our users are actually redirected back to the proper endpoint of our own custom server, that we can complete this authentication workflow and retrieve the access token. All right, we've got our application ready. And now for the integration with BIM 360, for example. If you do have a BIM 360 account and you do have an account admin, or you know someone who is the account admin for your BIM 360 account, what you'll want to do is head over to the account admin section of your account. Inside there, move over to the settings tab and custom integrations. Custom integrations are basically a security mechanism of BIM 360 that is used to whitelist Forge applications that are allowed to access the content of this BIM 360 account, right? So there are other standard security features of the Forge platform, like the three-legged authentication workflow. But on top of that, the BIM 360 account here uses an additional security layer where, in order for some custom Forge application to be able to query its data, we actually need to whitelist that Forge application. And we do that by adding a custom integration. That's what it's called. And again, the custom integrations are only visible to account admins under the settings tab. It's custom integrations. So you can see I already have a couple of Forge applications that I had registered or whitelisted in the past. So now what I'm going to do is I'm going to say add a custom integration, right? Here I can probably select just document management, because all my new Forge application will do is just read the the documents available in, let's say, some BIM 360 projects. All right, I'll say that I'm the developer, and here this is the important part. The Forge client ID, right? This is basically where we specify the client ID of the Forge application that we want to allow access to our data. So what I'm going to do is I'm going to go back to my Forge app that I've just created, copy the client ID, and paste it here. I'm also going to take, while I'm here, I'm going to take the app name and paste it here as well. Okay, and the BIM 360 account ID, not sure if we'll need it here. I don't think that's actually going to be needed, because when we log in with our Forge app, we'll basically see this BIM 360 hub as one of the hubs that we have access to. Xiaodong, is that correct? I believe that's the case, right? We don't need to note or store this BIM 360 account ID anywhere. At least I think that's the case. All right.
You need to tick it.
I'm sorry? Yes, I need to take it, but I don't need to
Yeah.
copy the BIM 360.
Oh, yeah, of course. Okay. Yeah.
Right. Is that correct?
Yeah, basically this is a hub ID you can store. And if you basically for developer who has not known the ID before,
Right.
but if you are the administration or you have been familiar with the hub, you can even find this ID in the browser address, right?
Okay, all right. So yeah, so if you as a developer would really need to know the ID of this BIM 360 hub, so that later on when you're building your application, you only, let's say, present projects from this hub to your customers, then you could basically, you would want to make note of the BIM 360 account ID. But as Xiaodong says, if you need to find it out later, you can also do that from the browser. So I'm not going to store it for now. I'm just going to check this checkbox saying that yes, I'm aware of this and that I've saved the account ID, and we'll hit the save. And that's it, right? So now we have another application in our list of custom integrations, and that means that my new Forge app using these credentials, this client ID and client secret, is now going to be able to access the data in any projects that might be in this Autodesk Forge DevCon account. All right, that is for the Forge app and the custom integration. And by the way, if you are maybe a bit lost and you want to get more details about what this means and why the custom integrations are needed, I would recommend that you head over to the documentation section on the Forge portal. And then when you go to, I believe, BIM 360 Developers Guide. Let me do something here. Give me a second. All right. So here in step-by-step tutorials, getting started, and again, that's for the BIM 360 documentation on the Forge portal, right? You'll find these manage API access to BIM 360 docs, and that basically explains the same process that I just followed, right? So as an account admin, heading over to settings and custom integrations and adding your new app as new Forge app as another custom integration, so that the app can later access the data owned by people using this in this BIM 360 hub. All right, this one I can close. And now for the runtime environment and development environment. Again, we're going to be using Node.js. If you don't have Node.js installed, you can simply head over to nodejs.org. And we would recommend that you get the LTS version. That's the long-term support. If you're already using a different version of Node.js, that should be fine too. We only ask that it's at least version 10. because some details of the implementation require the Node.js version to be at least 10 or beyond. With this, when you install Node.js, it'll also automatically install the Node Package Manager Npm tool. That's also something we're going to be using later to initialize our app and to install dependencies to our project. That is for Node.js. And then for the development, like I was saying, you're free to use any code editor that you prefer, whether that's Visual Studio or WebStorm or Vim or anything else really. But if you're looking for some suggestions, we definitely recommend the Visual Studio Code. That's you can find it going to code.visualstudio.com or simply Google VS Code. This is a free cross-platform and pretty fast and nice lightweight editor, sort of like a small brother of Visual Studio, I like to say. That's really good for web development, I believe, in my experience. So if you're willing to give it a try, simply head over to code.visualstudio.com and download and install the stable version. The editor looks kind of like this. It has, a file explorer. It has some, Git integration so that you can version your code from here, debugging support, plugins. One thing I was explaining yesterday as well was we've also implemented an extension for Visual Studio Code that allows you to browse the services and functionality in Forge right from the editor without writing any code at all. You can find it by going to the extensions section and search for Autodesk Forge. This is what the extension looks like. You can install it from here. I already have it installed. After installing, it'll appear in the sidebar as well as with the Forge icon. And when you run it for the first time, it'll ask you to enter the Forge client ID and client secret of your application, right? Because again, even this extension, when it wants to communicate with Forge, it will again need to authenticate itself in some way, right? So typically the way this extension works is that it allows you to specify one or more environments in the settings JSON file for Visual Studio Code. And you can then switch between these environments to use different Forge client ID and different Forge client secret, right? For maybe if you have multiple different products using different Forge apps. In my case, let me take a look at the settings. So when I go to settings of Visual Studio Code and I search for Forge, you'll see a couple of options, configuration options here. The one really important is these Forge environments. This is not a simple text. This is actually a list of JSON objects. So you will want to edit this directly inside the settings JSON file. You can see here, I already have my two environments from yesterday. It's actually the same Forge application. It's just in one case, it's accessing data in US servers, and in the other case, it's accessing the EMEA geo. Now, I've created a different app today here. So what I'm going to do is I'm going to copy the client ID and client secrets. You can simply double click the password here and let it copy to the clipboard. And I'm just going to keep this one environment available. That's it. Right. So now I have one environment with some Forge credentials that my extension can use to access the Forge data and Forge functionality. Now, of course, you shouldn't be showing the client secret to anyone. Right here, I'm, of course, sharing my screen with you. But for these reasons, what I'm going to do is after I'm done with the presentation, I'm going to hit this regenerate button that will ask Forge to create a new client secret for this application. And then after that, this one will no longer be valid. All right, so I've got my Forge environment configured. And now when I activate the extension, simply clicking this Forge icon, it's now basically communicating with Forge using the Forge credentials that I've provided for the environment, right? And for now, I don't have any buckets or objects uploaded in the Forge data management service, right? That's what we were doing yesterday with the basic Forge app. But you can already see that there is actually an experimental support for browsing hubs. And since we added the BIM 360 hub as a custom integration to this Forge app, we can now already see the hub and some of its projects in the extension here as well. But we could as well start, creating new buckets, data management buckets, and uploading files, translating them, and viewing them directly from here. So if you decide to give VS Code a try, we would highly recommend that you try the Forge extension for the editor as well. All right. Now, to make sure that you have Node.js installed and that you have the right version, what we're going to be using to set up our app and to install dependencies is just a command line, right? So in this case, I'm on macOS, so I'm using a simple terminal with Bash. If you're on Windows, feel free to use the command prompt as well. That should work just fine. So that's the CMD, right? Some people use PowerShell, but I'm not sure if PowerShell will work in the same way. So I would recommend avoiding that, at least for now. Again, just because it might work slightly differently from what we're going to be showing here. Right, so I have a simple bash shell. And what I'll try and do is I'll run the node command with a -v argument. And that should give us the number of the Node.js interpreter, right, the runtime. So in this case, I'm on version 14.17, which is good. That's what we want. And in the same way, I can try and type npm -v. That's the Node package manager that was installed together with Node itself. And again, that's the tool that's used to install and manage Node.js dependencies in your projects. And if I run it with a -v, you'll see that I have npm version 6.14 installed. Right, so this is really all we need to be able to start developing our Forge application and sessions here. Okay, that is it for session 1. And now's your turn. So what we're going to do is I'm going to pause the recording. I'm going to freeze the screen sharing. I'll leave the slide on for the next roughly 1.5 hours, I believe. We're pretty much on time. Yes. So for the next 1.5 hours, I'll leave this slide on, and you'll have that 1.5 hours to go through these steps that I just took, right? So make sure you have a Forge account that you can log into. Make sure you have a Forge application with client ID and client secret, right? Make note of those. We're going to need them in session 2. And if you have a BIM 360 account and you're an account admin, or an account admin, try and see if you can add your new Forge app as a custom integration to the hub. And again, if you cannot, that's fine, right? You'll still be able to access your content from some of the other Forge-based applications like Fusion 2. And finally, make sure that you have some kind of coding editor available for building the app, and that you have Node.js and npm available in the command line. That's what we're going to do. That's what we're going to use to initialize our app. All right. And if you have any questions, feel free to use the chat or the Q&A buttons in the Zoom toolbar. I'll be monitoring these, and I'll try and answer your questions as we go to make sure that when we meet again at 10 a.m. GMT time, that we're all ready to move to session 2 and start building the app. All right, so I'll see you then. All right, here we are. Welcome back, everyone. We're going to move on to session number 2. I see a question in the Q&A. Do I need BIM 360? You don't need a BIM 360 account. It's good to have one so that you can explore some of the different types of hubs, and so that you could then use your new Forge application that we'll build today to explore your data in the different products. But if you don't have access to BIM 360, that's totally fine. There are other products built on top of the Forge platform, such as the Fusion teams. If you go to a360.autodesk.com, let me actually show that real quick. You go to a360.autodesk.com. This is where you can also try in collaboration with teams on your designs. And this is yet another existing product that's been built using the Forge platform, and another product that you will be able to access from your custom Forge application, or in other words, where the users of your application will be able to browse their content from A360. So BIM 360 is not required. All right, with that, we're moving to session number 2, where we're going to start building our Node.js server of our Forge application today. And we're going to introduce some authentication endpoints to it as well. Now, just to repeat this simple diagram that we also showed yesterday, the way it's going to work is we're going to build a simple server application in this webinar using Node.js that's going to access some of the functionality from Forge, right? So it'll use the authentication service to generate tokens. It'll use the data management service in Forge to get a list of hubs, projects, folders, items, versions that our users may need to see. And then our custom Node.js server will then format the data in a structure that we expect on the client, and it'll provide this information to the client. So our client-side code, HTML and CSS and JavaScript, in most of the cases, it will not be talking directly to Forge, but it'll be requesting all the Forge data through our Forge app, right? So almost all the communication will be funneled through the Node.js server. There is, however, an arrow connecting the client-side code directly to Forge, and that's actually the moment when we start loading some model into the viewer in our new Forge app. The viewer will need to start communicating directly with Forge to download all the different visuals, the geometry, the textures, and the metadata, all that, right? So that the model can be loaded on your web page. That is the one moment when the client-side code of the app we're building today will actually communicate with Forge platform directly. Otherwise, most of the communication will funnel through our Node.js server. So this is the same diagram we showed yesterday. We have one more prepared for you today. This is actually copied from the Forge developer portal. And today, what we're going to use, something that's different compared to the app we were building yesterday, is the three-legged authentication workflow. And again, the app we're building today will not be managing its own data as the app from yesterday did. Today, the application will simply ask the user to log in. When the user clicks the login button, we will redirect them to Autodesk servers, where they will be asked to log in and confirm that they want to allow our Forge application to do certain operations. That's the scopes we talked about yesterday as well. So whenever you want to generate some kind of an access token, which is a temporary string that can be used, that has some limited time to live, and that can be used to execute different operations within the Forge platform, we always specify the set of scopes that we want that token to have. In other words, it's the different types of privileges that we want that token to have. For example, there is one scope called data read, which is basically asking the access token to be able to read information from the data management service. Then there is data create or data write, right? In which case we are asking for an access token that would actually allow us to even modify the data in Forge. And when you choose this set of scopes and you go through this three-legged authentication workflow, when the user is redirected to the Autodesk servers, the Autodesk website will actually ask them, this Forge app is trying to do this, right? Access your data, modify your data. And then when the user says, hits the allow button, he's redirected back to our application, to that specific callback URL that we discussed in the previous session, right? And on that specific URL, we receive a temporary code that, using the Forge authentication APIs, we can then exchange for the actual access token. So that workflow is explained in this diagram, right? So we redirect the user to the Autodesk login forms. The user consents that, yes, he allows the Forge application to get a token for the specified set of scopes, in other words, for the specified set of privileges. And when the Autodesk servers are redirect the user back to our server, we need to have some URL where we'll be able to receive this temporary code from Autodesk and exchange it. That's the step 4 here, exchange the temporary code for the actual access token, right? And that is what we're going to do now in session 2. We're going to start again by initializing an empty Node.js project using the command line tool, npm, and we're going to install a couple of dependencies. And for those of you who decided to use Visual Studio Code, we're going to define something called a launch configuration. So that will be a little piece of JSON using which we can then simply run and debug the server-side application right from the editor. We can put breakpoints in the code, step through the code, watch the state of the variables, etc. And we're going to start building the Node.js server itself. So again, just like yesterday, we're going to have a start.js file that's going to define our express.js server and a config.js file where we're going to try and collect all the inputs we need from the environment variables. And we're going to implement a couple of the authentication endpoints in our server in order for the user to be able to log in, right, to be redirected to the Autodesk server, and also to be able to handle the redirection when the user provides his consent and he's redirected back to our application. All right, demo time. Let's take a look at the LearnForge website again. So now today we're following the ViewBin 360 Fusion Models tutorial, and now we're moving to first step, create a server. And again, today we're using Node.js. So here's what we're going to do. In the command line, I'm going to create a new folder for our project. I'm going to call it day2. Yep. So we're now in a new empty folder that's going to be our project today. And inside there, I'm going to type npm init. This will basically initialize a new Node.js project. For now, it'll just be a package JSON file. That's sufficient. The npm init command will ask you a couple of questions: how you want to name your package, version, description, author, repository keywords, etc. You can just leave everything as is. Now, and after that, you'll see that basically there's just a single file created by the npm tool, package JSON. We take a look at it. For now, it's just a simple JSON describing our app, right? Who built it, and more importantly, if it has any dependencies, any other npm modules that we might be using. We will use a couple of external npm modules today, again, just like we did yesterday. We're going to be using slightly different ones. Today, if you take a look at the LearnForge website, we're going to be using Express again. So Express is the popular web server framework for Node.js, right? It allows you to very easily build all sorts of web applications or web server applications. Then we're going to be using the Forge APIs again. These are the official Forge SDKs for the Node.js language. So instead of you, again, having to manually put together HTTP requests, send them to one of the Forge services, and then wait for the response and somehow extract the information from the response, you can use the Forge APIs instead. And in there, all that functionality will be abstracted into classes and method calls. That's what we're going to use today as well. And finally, the third dependency here, cookie session, is something we're going to use to actually store and cache some of the authentication data in our user's browser, right? So when we ask the user to log in and when the user is redirected back to our server and we exchange the temporary code for an access token, we don't want to just discard it, right? We want to store that access token somewhere so that when the user comes back, let's say 1 week later, we don't want to ask him to log in again, right? We want to be able to see if he still has some access token that's still valid that we can use to have him enter the website directly, immediately, right? A very common approach to handle this user browser-specific caching is using cookies. And for this, we're going to be using Cookie Session, which is basically an Express.js plugin, right? It's an additional middleware. That's also something, a concept we explained yesterday. Middleware is basically a piece of logic that you can put on sort of a stack in your server application, and every incoming request will go through this stack of different pieces of logic where individual middlewares can either choose to ignore that request or they may choose to react to it and respond to that request, right? So Cookie Session will be a middleware that will take a look at every incoming HTTP request. And if it sees any cookies there, it'll basically parse them for us and make them available on the request object so that we can later read the cookie data from the request object in any other custom URL endpoint handler or any other custom middleware that we implement. All right, so let's install these 3 dependencies now. Still in the command line, I'm going to install all of them together. So I'm just going to type in npm install express cookie session and forge APIs. And I'm also going to add the --safe argument, which will make sure that these 3 dependencies are not only installed to this project, but also recorded in the package JSON file, so that if we share the source code with anybody else in the future, they will know exactly which dependencies our code requires. And this safe command will also capture the versions of these dependencies as of the time of the installation here. So now if we take a look at the package JSON again, you'll see that it's now been automatically updated by the npm tool, and it includes these 3 additional dependencies, right? And as of now, the latest version for these 3 dependencies was this 1.4.0 for the cookie session and 4.17 for the Express framework, right? So if we share this source code with anybody else, with one of our colleagues, they can simply run npm install command in the same folder where the package JSON file is located. And npm will know exactly which dependencies to install and which versions of these dependencies to install. All right, that is for our dependencies. And now we'll also modify the package JSON scripts. And let me explain what that means. But for now, I think for now we're fine to leave the command line and we can move over to our editor. So in our case, I'll be using Visual Studio Code, and here I haven't opened any folder yet. So I'm going to use this open folder button and navigate to my day 2 folder that I've just created. And here, basically in VS Code, you don't have any special solution files like in Visual Studio. Here, you basically just open a folder, and a folder is your project. It's your workspace, right? So in the folder that I've just created, I only see my package JSON, right, with the 3 new dependencies. And I also see a log file that was generated automatically by the npm tools. Also capture the exact versions of the dependencies that we've installed, but also to capture all the versions of their dependencies, right? Because we can get a complete dependency tree where our Express framework may depend on another npm module, and that module may depend on another set of npm modules. So the log file captures the versions of all the dependencies in the tree. Here it's basically flattened into a list. And node modules is the folder where the flattened list of dependencies is actually installed, where our code is going to require the dependencies from. All right, that is our basic folder structure. And now what we're going to do is we're going to add a script into the npm into the package JSON file. So you'll see the package JSON may contain a property called script, which is an object, a dictionary of different commands that you may want to run, let's say from the command line. Here, what we're going to do is we're going to add a new script called start, which will basically just call node start.js. So eventually, as we create our start.js file, we are adding this script called start for convenience, so that later on we can simply type npm start if we wanted to in the command line, and that would basically translate to this command line called node start.js under the hood. All right. Well, let's also create a couple of folders that we're going to be using momentarily. We're going to create a folder called routes. And just like yesterday, this is where we're going to be building all the different Java Node.js logic for handling all the different server-side endpoints or routes. And we can also prepare a folder called public, which is where we're going to store all the client-side assets that we're going to build in, that we're going to implement in the last session today, right? So here's where we're going to store all the HTML, CSS, and client-side JavaScript assets that we will want to make available to the browser when the user enters our web application. All right. And finally, again, if you're using Visual Studio Code, it's a good idea to create this thing called launch configuration, which is basically a description of what you might want to run from within Visual Studio Code. If you go back to the editor and you look at the run and debug section in the sidebar, you'll see that for now, it doesn't really, Visual Studio Code doesn't really know what we wanted to run or debug, right? So what you can do is you can use this link, this quick action called create a launch JSON file. This will create this JSON file under a folder called .vs code, which is used to specify different Visual Studio Code specific settings, right? The first thing you'll be asked for is what kind of launch configuration you want to create, what kind of application you want to run from VS Code. In this case, we're going to choose, hopefully you should see Node.js in there, since we're building a Node.js application. So that's what I'm going to do. And here you can see that it automatically created the .vs code folder for us and the launch JSON with our first configuration. Right, so you can see we can actually have multiple launch configurations set up for our Visual Studio Code project. Here we have just one. The type is PWA node, or you may see node in there. We gave it some name, in this case, just as a launch program. And here we're basically telling it which JavaScript file to use with the Node.js tool, right? I mean, with the Node.js runtime, which file we want it to run. We don't have any file here just yet, so we're going to create one. In the root of your project folder, we're going to define a file called start.js. Here is where we're going to define our Express.js server. So now what we can do, if we go back to launch JSON, we will basically want to make sure that when we run and debug the application, that we will run this start.js file from our workspace folder. Now what we can do is, let me see if I remember it correctly. Yeah, workspace folder. Right, we can maybe just copy this line from the LearnForge website. So we're basically saying when we debug this application, we want you to run this file in our workspace folder, start.js, using Node.js. And then we can also specify a dictionary of environment variables that should be made available to the Node.js process, right? And this is a common way when developing server applications in Node.js, but even with other languages, this is a common way of providing some configuration inputs to your application, like maybe some connection strings or passwords or stuff like that. But here, we're also going to need to pass a couple of information inputs to our app. In this case, the Forge client ID, Forge client secret, and the callback URL, right? So that's what we're going to need, and we can copy these. Maybe let me copy these from LearnForge as well. All right, here is my env, right? These are my 3 environment variables that I will eventually try and read from my Node.js server application. Let me go back to my Forge portal and copy and paste the client ID in here. Client secrets as well. All right, and now for the callback URL, let's use this one. I mean, it's totally up to you what kind of URL in your server you want to use for the redirection when your users log in and provide consent for your app to have access to their data. By convention, in our Learn Forge tutorials, we use this URL on our server, the /API/forge/callback/OAuth. So it's a bit of a mouthful, but again, for consistency, we're going to use the same URL here because again, it's consistent with the official Learn Forge tutorials. This is basically the URL where again, our users will be redirected to after they log in and provide consent that yes, they allow our Forge app to access their data. And this is the endpoint where Autodesk is going to provide some temporary code that we can then exchange for the actual access token using the Forge authentication service. So let's make sure that we're all on the same page. Let's copy this string from the URL from the Learn Forge website and use it as our callback URL. And while we're on it, let's also go back to our Forge application on the Forge portal and make sure that the callback URL in the app information is the same. This is critical because if these 2 URLs differ in even just one symbol, when you try and redirect the user to the login page, Autodesk will actually warn them, oh, by the way, be careful. The callback URL for this Forge app, it doesn't match the callback URL that we're actually being asked to redirect you to. So in your on the Forge portal, edit your application and make sure that the callback URL is available, that it matches exactly what we've configured in our Node.js server code. All right, I'm going to save this. Now we should be good. Now our callback URL defined on the Forge portal should match exactly the callback URL that we're going to be using in our Node.js server code. All right. And now we can finally move over to start implementing our Express.js server. So again, let me, instead of typing this out by hand, let me copy the Start.js content from the Learn Forge website and add it, paste it to our Start.js script and explain what this does. Just like yesterday, we're basically importing a couple of npm dependencies. Path is a module available to Node.js itself in its standard library. Express is the Express.js web framework that we've installed as a dependency using the npm install command. And cookie session is the plugin for Express. That's the middleware that we can plug into our server's stack that will handle all the incoming requests looking for any cookies, looking for cookies if there are any. And it'll actually handle all outgoing responses as well. And it may store cookies in the outgoing responses as well. That's how the stack of middlewares functions. All right, what we do here first is we try and retrieve the port number from the environment variables available to our Node.js script through the process built-in variable. So process.env just lists all the environment variables that were made available to our Node.js application. We try and read a config.js file, which is not here yet. We're going to create that one momentarily. And we check if inside that config.js file, if any client ID and client secret values are defined. And if not, we just error out and return immediately without starting the server at all, right? So the Forge client ID and Forge client secret are the environment variables are required. So if they're not available, we just return immediately without starting any server at all. And finally, on line 12, this is where we start, we initialize a new Express server application. And through the app.use calls is where we actually start building this stack of middleware. So we use, for example, one middleware that's available directly on the Express module called static. And this is basically a middleware that will take a look if the incoming request is maybe asking for a file available in certain folder, in our case, in a public subfolder, right? So if the incoming request is looking for a file called, again, like the example I used yesterday was image.png, right? This middleware will take a look into the public folder if perhaps there is a file called image.png. And if there is one, it'll respond to the request immediately, skipping any other middlewares on the stack, right? Next one is the cookie session, right? This is the one that's going to take a look at every incoming request. If it contains any cookies, it will parse them for us and make them available on the request object that we can then access in our own code. And in this case, it can even encode and decode encrypted cookies, right? So in this case, we're using a set of keys or just one key. So it basically means whenever we send a response back to the client, this middleware will make sure that all the cookies we potentially set on that response will be encrypted with some secret. And when we, maybe 1 week later, when the user goes back to our web page and we receive a request with some cookies that are encrypted, this middleware will also be able to decrypt them for us. So this, I hope you can now see this benefit of this stack-based, middleware stack kind of approach, where in our code, in our custom code in our Node.js server, we don't really have to worry about manually reading and writing cookies, right? We just insert a middleware into the stack so that before the code execution reaches our code, our custom server-side code, all the cookies will already be parsed. And the same for the other way. When we send the response back to the client, we don't have to worry about manually encrypting something. We just set some cookies on the outgoing response object. And then after that response hits this cookie session middleware again, the cookie session middleware will make sure to encrypt the cookies for us. And then we use, again, another built-in middleware from Express for parsing JSON payloads, right? So when we receive a request that says that it contains some kind of a JSON, this middleware will parse the JSON for us automatically and make it once again available on the request object. And here is where we're going to start inserting our own functionality on the stack to the Express application, where we're basically going to implement some kind of something called Express Router, which is a collection of endpoints that can be handled in a certain way, where we implement specific handlers for these URLs, and we can then mount these routers to different prefixes. In this case, we mount them to API Forge, all of these. So these are going to be the different endpoints of our server application where we will implement our own customized logic to handle these endpoints. And finally, there's the catch-all, again, middleware that basically will be used when no other middleware in the stack was able to answer or react to the request, right? So in this case, if no other middleware was able to react to the incoming request, it probably means that that request is wrong, right, or unexpected. So what we do is we, again, log it to our console and respond with some status code and JSON with the error message back to the client. Finally, we're running our application on the specified port number and inform the user that the server is now listening on that port number. That's for our start.js file. Now, as you saw here on line 6, we're going to need to use this add a config.js file. That is where we're going to try and collect all the inputs that we need from the environment variables. If I go back to the LearnForce website, you'll see the content of the config.js file here. So let me once again just copy it, paste it to our folder, and explain what this means. Here, all we do is we're basically just building a single JavaScript object with two top-level properties, credentials and scopes. And we are then exporting this object from this file from this JavaScript file so that it can be imported in other Node.js files. And that's precisely what we're doing in our start.js on line 6, right? Where this is where using the require built-in function in Node.js, we're basically importing whatever that config.js file is exporting. So in this case, config will be this JavaScript object, right? With the parameters that we define here. So this is a nice way of, unifying. If you have like some configuration or set of config values that you want to be able to access from different places in your Node.js application, this is one way to go about that, right? To basically move all this configuration data into a single file, and then you can require this config.js from wherever you need to. And inside this custom JavaScript object, we're basically under credentials, we're defining another JavaScript object with the client ID, client secret, and callback URL properties received or extracted from, once again, the environment variables, right, of the process where our Node.js app is running. So this will be, in our case, provided by the launch configuration. So Visual Studio Code itself will run our app and provide these 3 environment variables. And in our config.js file, we're going to read them into this config object. Now, as a slight side note, for those of you who are using different editors, you will probably need to configure your IDE a little bit differently, or when you want to run your app from the command line, you'll actually need to make sure that these 3 environment variables are provided, right? Because for now, for example, let me just comment out these 3 middlewares because we haven't implemented those yet, right? But now if I try and run the app simply from the command line by running, node start.js, for example, see that we've actually hit this if condition on line 7 saying, oh, by the way, you haven't provided any forge client ID or forge client secret. So if you're not using Visual Studio Code and you want to run your app, let's say from the command line, you will need to set the environment variables in there or in any environment where you may need to run your application from, right? In this case, since this is a bash shell, I would have to do something like export forge client ID equals something, right? And export forge client secret equals something, right? In your, if you're on Windows, if you're using the command prompt, I think the command there is different. I think in case of the command prompt on Windows, it's set. So you would have to do something like set forge client ID equals something, right? Or set forge callback URL equals something. So be careful. Again, if you want to run your app from a different environment, you need to make sure that the environment variables are somehow defined in that environment. All right, that is for our start.js or server file and the configuration. And of course, just like yesterday, we're also specifying 2 sets of scopes. One set we call internal. This is going to be the scopes that we're going to be generating the access token for just for internal use. We're not going to be sharing that token with anyone because that token will be able to create buckets, read data, create data, override data. So we definitely don't want to share this token with anyone because whoever gets hold of that token could then potentially make requests to Forge to modify our Forge apps data. We don't want that. So this token generated for these scopes will only be used internally. And then we will have another set of scopes, in this case, just one scope called viewables read, that we're going to be using to generate a public token that we can share with the client side. And that's a token that the viewer will use to actually load models from Forge. All right. And now we can move on to the first Express router that we're going to be implementing, where we're going to implement all the different authentication and authorization endpoints. So again, now we're moving to the authorize step of the View in 360 and Fusion Models tutorial. And now here's what we're going to do. Under the routes folder, we're going to implement our first router for the authentication, where we can name the file, in this case, just to be consistent, oauth.js. And let me copy the content and again explain what it does. So go to the routes folder in your project and create a file called oauth.js and paste the content, the snippet from the LearnForge website. What we're doing here is, again, see, we're reading the configuration object from the config.js file that we created a moment ago. And we're importing this helper class that we haven't defined yet. That's going to be in another JavaScript file under a common folder here. We're going to create this one momentarily. And we're defining a new express router. So again, a router is a collection of endpoints, server-side endpoints with custom logic to handle them. Then these routers can then be mounted to different URL prefixes in your server application. So in this case, we're defining a single router, right, and exporting them out of this JavaScript file. And the router can handle 1, 2, 3, 4 different URLs. It can handle requests to URLs ending with /callback/oauth. And to handle that, what it'll do is it'll create a new instance of this helper class that we will define in a moment. And it uses it to basically call this setCode method. What this will do is, this is where the user will be, this is the endpoint the user will be redirected to after they log in and provide their consent, right, for our app to access their data. With this setCode method, this is where we're going to take this temporary code generated by Autodesk and exchange it for an actual access token. So the authentication service in Forge. This one, if somebody makes a request to our server to a URL ending in /oauth/URL, what we do is basically we just generate a URL to redirect the user to so that they can log in, right? This is the actual URL where the user will be asked to log in and confirm that, yes, they approve, they allow our application to access their data with the scopes that we specified here, right? So by calling res.end, we're basically redirecting the user to this URL. And then for sign out, if somebody goes to a URL ending with oauth/signout, all we do is on the request object, there is a session object, and that's actually the object generated by the cookie session middleware. We simply set it to null, we remove it, right? So that when the response redirects the user back to the index page, which is done through this .redirect method, the cookie session will notice that we intentionally cleared the session object. And with that, the cookie session middleware will clear all cookies on the outgoing response for us. Okay, and finally, there's going to be an endpoint that's going to be called by our own client-side code to obtain a simple public access token for the viewer, right? So that's, and again, we're going to use the helper OAuth class that we're going to define momentarily. And we're going to use it to generate a public token. Again, that's going to be the token that only has the single scope, the single privilege, which is reading converted files from the Forge model derivative service. And now what we're doing in the start.js file is we are mounting this router. See, here we call the require again. So we are importing this OAuth JavaScript file. In other words, the router from it. And we are mounting it to /API/Forge. So all these endpoints that we've defined here will basically be added to /API/Forge. So this code will be executed whenever somebody makes a GET request to /API/Forge/callback/OAuth. All right. Now for the helper class, let's go back to the LearnForge website. You'll see that this helper logic will be placed in a common subfolder in the routes folder in a file also called auth.js. So let me copy the content of this one. Let's go back to our project. Under the routes folder, I'm going to create a new folder called common And inside there, I'm going to create a new file also called OAuth.js and paste the content into it. Now, what this is doing is we're now importing one of the classes from the Forge SDKs, right? And this time it's the auth client three-legged. So this is going to be a class used to handle the three-legged authentication workflow. And then we define a custom helper class called OAuth that we then export from this script so that it can be used by other Node.js scripts, namely by our router here. So what the class is doing, when it's instantiated, we ask you to provide the session object right from the express request, and we store it locally. And then we provide a couple of helper methods that we use throughout the code, right? So if we look at the router, like the first example, what we use when this is the callback URL, right, that the user is redirected to after they log in. What we do with this helper class is we instantiate it, right, using the session object on the request. And we call set code. If we look at set code method here, what will happen is we basically call this Forge SDK method called getToken on the instance of this auth client three-legged class from the Forge SDKs. And the getToken is pretty much the same thing as, let me see if I can find that for you. Boom, we go to the documentation on the Forge portal. We look at the authentication reference. GetToken, the getToken method basically under the hood makes a request to this getToken endpoint of the authentication service in Forge. And this is used, as you can read here, to exchange a temporary authorization code for an actual access token. So that is what the set code helper method is doing, right? It's calling getToken with our temporary code that we received from Autodesk in the callback URL. And it's using then also to refresh a token based on the newly generated token with only the public scopes, right? So what this is doing is basically generating two access tokens, one with the internal scopes that we've configured in the config.js file, and one with just the public scopes, the viewables.read. And then we store this information in the session, right? That's the cookie session object maintained by the cookie session middleware in the Express server app. So we store this information as 4 different properties on the session: internal token, public token, refresh token, and some expiration information. That's what we do there, right? And then we redirect the user back to the index page. So when you log in and you're redirected back to our app, we use the code to generate our access tokens and redirect you back to the index page. All right, and here we're also using this helper class when retrieving the two-legged token so that we can send it to the client as a JSON and use it by the viewer on the client side, right? So here again, we just create a new instance with the session data. And then we call get public token. And all this does, right? It just checks the tokens from the session, from the cookie session, checks if those tokens are valid or expired. If they are expired, it will refresh them, and then it'll return the new access token with just that one scope, viewable free, right? That's the public token that we're free to share with the client side. Okay, and that is it. Now, let me, I uncommented this line of code. So now if we run our application, and let me run it actually from here, because I've added my launch configuration, right, for Visual Studio Code called launch program. If I switch over to the debug or run in debug sidebar, you'll see that I already have my configuration here available with that name. So I can run it from here. You can see now our server is now listening on port 3000. So what I can try is I can move over to here and open, maybe go to localhost 3000. I will get an error because, of course, I'm now asking for this index page, but there, or endpoint, but there is none. That's the same thing as if I was asking for localhost 3000/foo. There is no middleware or custom router that could respond to /foo endpoint, right? So I'm going to get, this is going to hit the catch-all, the last middleware in the start.js file that just outputs a message saying, no, failed. We could not find any logic to handle /foo endpoint. But we can already try something. If I go back and look at the code, and look at the OAuth router, you can see it again, like if we want to redirect the user to some login page, we're going to send them to /API/forge/OAuth/URL, right? So let me try that. This is, so if we go to this page, to this URL, and again, we need to, this router is mounted to this API forge prefix, right? So we need to include the prefix in the URL as well. If I go to /API/forge, and then /OAuth/URL, this should redirect us to the Autodesk servers, as we discussed. Oh, sorry. Well, actually, this just sends us. Excuse me. Sorry. So this doesn't redirect us. This is actually sending the content, the URL, back to us. So that's probably what the JavaScript logic will use later on as we build the user interface. So for now, what we can try, let's see if this works. We can try and copy this URL where we should be redirected to eventually by the user interface, and see if we can run it from here. All right.
Peter, I think select problem from the slash. You will see the callback URL has slash, not encoded.
Right. I thought that maybe Chrome would encode it for me, but you're probably right that that's not the case. But anyways, I was just curious if we could maybe allow you to try and run the ad before we build the user interface, but there might, I think you're right. Simply copy and pasting the URL into the address bar may not work because all these slashes and spaces may not be interpreted correctly. So I'll probably have to encode these. So you probably don't want to, or you don't have to try these now. Yeah, we'll basically double check if this implementation is correct when we move to the UI, the user interface implementation in session 4. All right. So now it's your turn again to follow these steps. And again, define, create new Node.js project, install the dependencies. If you're using VS Code, you can create your launch configuration to be able to run and debug the app from within the editor, and start building your server, Express.js server with start.js and config.js files, and add your authentication endpoints by following the Learn For tutorial. And if there are any questions, I see there might be one already. All right, so no questions for now. If there are any questions, let us know in the Q&A or in the chat. And again, I'll be monitoring these. And we will see you back here in roughly 1 hour and 10 minutes at 12 p.m. GMT time. All right. Thank you. Okay, we're recording. So once again, hello everyone, welcome back for session number 3 of our day 2 event of the Forge Online Bootcamp. Before we get started, let's give a moment to anyone who might have some additional questions regarding the previous sessions today. And while we're waiting for any of the potential questions, let me quickly explain what happened at the end of the last session. So, I've been trying to basically run the app, even though we don't have any user interface for it yet. But I was just trying to see if we could maybe test some of the endpoints before we implement any, HTML. Yeah, that's going to be the topic of the final fourth session. So and I wasn't quite sure what was happening there, but now I believe I do. So let me start the app one more time from VS Code. And I've already put a couple of breakpoints into these endpoints that our authentication router handles, right? So this is, again, the /API/forward/callback/OAuth. That's the callback our user will be redirected to after logging in and confirming, providing consent, right, that our application is allowed to actually access their data. And this is the endpoint that's simply going to return a string. So it's not going to redirect. I was wrong before. The res.end will actually just close the response with a simple piece of content. In this case, it's going to be a string. And that string will contain the URL that the client side will actually eventually redirect the user to, so that we can initiate the three-legged authentication workflow. So let's see what happens here. Okay, so our app is running. I've got my breakpoints ready. And now what I'm going to do is I'm going to head over to, actually what I'm going to do is I'm going to open a new tab in an incognito mode. And I go to localhost /API/forge/ what was it again? Callback, no, sorry, the OAuth/URL, right? So this should just give us a string that contains, and I see we now hit the code on our server side. So this should just return a string containing the actual URL for our login. Now, Xiaodong, my colleague, pointed out correctly that it's not exactly safe to just copy and paste into the URL, into the address bar, because this long URL already contains stuff that's kind of not safe for URLs in general, right? So you can see we're passing in a parameter, but that parameter itself also contains like slashes, right? So we're not sure if, this could confuse some browsers and our server applications, right? So there's like these additional slashes, additional, ampersands and spaces, right? But in this case, in case of Chrome, if I paste this URL with all these dangerous characters into the address bar, Chrome will actually URL encode all these properly. So when I do that, you'll see that now I'm actually redirected to Autodesk, and Autodesk is asking me, oh, by the way, somebody is trying to, this Forge app is asking you to allow it to access your data somewhere, let's say, Vim 360 or Fusion Team. So what I'm going to do is I'm going to say, Petr Broz, Autodesk.com. Oh, all right. Not if I remember my, nope. All right, I don't. All right, I should remember my Autodesk account, but I don't. So let's do it a different way. I'm going to initiate the workflow one more time, but I'm going to use my personal account. All right. And now you see that we've actually intercepted the callback where Autodesk redirected the browser back to our app after I logged in successfully, right? So this is the temporary code. We're going to extract it from the query, right? So rec.query is contains a collection of any query parameters that came with the incoming URL. Okay, so now what we did is we basically used this temporary code and exchanged it for a couple of tokens, right? So we've generated the internal token, public token, refresh token, and we've defined also the expiration time, and we stored all that information in the requests session session object here. Right, so now as we send the response back to the browser, redirecting us to the slash to just the index page, the cookie session middleware will make sure to actually store these cookies in our browser. So even though we get this cannot get slash, right, because our server still doesn't know how to respond to that request. If we take a look at the DevTools and we look at the application cookies, you'll see that for this localhost domain, we already have some kind of cookies stored here. And if you try and view it, you'll see that it contains some unrecognizable data. And this is actually, if you remember, if you recall from our start.js file, see, this is the name of our cookie. And that long string is basically all our session data, the internal token, the public token, the refresh token, the expiration time, all of that encrypted with some secret key, right? So this is even, and then next time I come to this page, maybe next time I come to API forge OAuth token, I believe was the last one. See, now we've intercepted the request in our router here. And now if I take a look at rec.session, you will see that the cookie session middleware has actually read and decrypted all the cookies for us, right? So I can now again see the expiration time, internal token, public token. All these four properties are hidden inside here and encrypted. And the cookie session is automatically decrypting and re-encrypting these for us. All right. So that's just to explain why I was a bit confused by the message I was getting from the server app, but that was because when initiating the three-legged workflow, Autodesk servers actually remembered that I had already given my approval before. All right, so let me remove the breakpoints and we can move on to the next step, as I see there are no other questions. Session 3, we're going to enhance our server, our Node.js server application, so that we're going to expose a couple more endpoints that our client side will then use to get the list of all the different hubs the user can access to. And in this context, hubs are basically the different silos of data, different products, right? So if you have a BIM 360 account, that can be one hub. If you are using Fusion Team, any projects in there will be part of another hub, right? ACC, Autodesk Construction Cloud, can be another hub. So we will extend the server, exposing additional endpoints that will allow us to list hubs, and then to list all the projects inside these hubs, and then to list folders and items, documents and versions of these documents inside the project, as well as to get some additional information about the user who just logged in, right, through the three-legged authentication workflow. All right. Now let's go back to our Learn4 chat, Learn4's website. We're moving over to the third step of our tutorial, list hubs and projects, right? This, once again, this diagram explains the structure in the data management service in Forge, right? So at the very top level, you have, again, a hub that may contain one or more projects, and then projects may contain one or more folders or items. Folders, of course, can be nested and can have items or files in them as well. And then every item can have multiple versions. And ultimately, these versions, really what they do is they point to one of the raw objects in a bucket, right? That's the content we were working with yesterday, where we were creating buckets and uploading objects and translating objects, right? So this concept of hubs, projects, and folders and items and versions really built on top of the OSS, the object simple storage. part of the data management service. Okay, now again, we're working with Node.js today. So what we're going to start with is we're going to start building another Express router that's going to handle all the different requests related to the data, the hubs, projects, folders, items, etc. So we're going to create a file under our routes folder called data management.js and populate it with this code. And we'll quickly explain what that does. Boom. All right. So let's go to routes and create a file called data management.js and paste our file in there. All right. What does this do? Again, we're defining an Express router, right, that will handle a couple of different endpoints. And then in our start.js file, we will mount that router to the same prefix like we did earlier, right? So in this case, if I look at the, let's say this /data management request, right, this router will basically handle any GET request to /API/forge/data management. And what it'll do is, first of all, it'll try and get an ID parameter from the URL, if there is any. If not, it will complain, it will respond with a 500 error back to the client, right? And here's what we're going to use it for. We're basically going to rely on this ID parameter in the URL to specify what exactly we are trying to get the list of. If the ID parameter is simply going to be set to a hash sign, we're going to return a list of hubs. Now, this helper function get hubs is not yet defined. We're going to add it later. We're going to append it to this file later. This is now just the beginning of our router here. Next, if by any chance, if the ID query parameter in the URL is not just a hash sign, what we'll do is we're basically going to take the string that comes in the ID parameter in the URL and we'll split it by slashes. That's just our convention that we came up with for this particular demo, right? We basically just said, okay, what we're going to do is in the ID parameter, we're going to store like the type of resource we want to list and maybe some ID of the resource, right? So here, and we separate it by a slash. So it could be something like project / and some name of a project, or folders / and some ID of a folder. So that's what we do here. We split the ID parameter from the URL by /, and we expect that it'll have at least two, it'll be split into at least two parts. And then we take the second to last item, we take it as the type of resource, right? That could be, we will expect strings like hubs, projects, folders. And then the last item in the list, we will expect to be the ID of that corresponding type of resource, right? So again, if the ID parameter is hubs / something, we will run this branch of the switch statement, of the switch expression, and we will run some helper function called get projects, collecting all projects in a specific hub of a specific hub ID. And similarly, right, for the nested structure. So if the ID parameter coming to our server is projects / something, we're going to try and get the list of all folders inside a specific project ID, because in this case, we expect that anything after the / project / will be this ID of a project. And then if it's a folder / something, we will try and get the contents of everything inside that folder. Again, using a helper function called get folder contents. And if it's items / something, we will take that something, consider it to be an item ID, and we will use another helper function, get versions, to ask the Forge data management service to give us to provide a list of all versions of that specific item. All right. Now we need to fill in these helper functions: get hubs, get projects, get folders, get folder contents, and get versions. And you'll find these on the Learn Forge website after the initial code snippet, right? So here's our async function called get hubs, a function called get projects, get folders, get folder content. So let's again copy these and paste them at the end of the data management JS file. And we can quickly go through these. So basically, all these helper functions, all they do is they just use the classes from the Forge SDK that we import here, right? So you can see we are importing a couple of different classes from the Forge APIs, the official Forge SDK. Classes like the Hubs API, so that we will be able to get a list of hubs. Projects API class will allow us to get a list of projects, folders, and items in the same way, right? So for example, the get hubs helper function, what it does, it creates a new instance of this Forge SDK class, and it calls this asynchronous get hubs method on it. And then it responds with a JSON that is basically the response we got from Forge, reformatted slightly, right? So we're not returning the same JSON response we received from Forge. We're actually taking the response from Forge, reformatting and changing the JSON structure a little bit so that we can, again, later on, easily use this data in the user interface, in the tree view component, right? So we even have a helper function here called create tree node. And what this does, it basically just creates this expected JSON structure that the tree view component in the user interface will expect. Again, if you remember, if you joined us yesterday, right, we were intentionally returning buckets and objects using this specific JSON structure. Basically, JSON objects containing properties like ID, text, type, and Boolean value called children. These will be used by the tree view component then to allow you to browse through your hubs, projects, folders, items, and versions. And similarly for the other helper functions as well, right? So once we have some kind of hub ID, we can ask for a list of projects inside that hub. So we once again create an instance of this Forge SDK class, and we call another asynchronous method on it called get hub projects. And again, we format them in this tree view node format and send it back to the client in the response as a JSON. Similarly for folders and folder contents and versions. All right. And that's pretty much our data management service, our data management router handling. So there's just going to be a single URL, right? The /API/Forge/data management, a single URL that will return that we will respond to in a different way depending on the ID parameter that's incoming. All right. And one more slight update to our server. We will also add another express router that will provide additional information about the current user who finished that three-legged authentication workflow, right? And we will simply use this to, well, for two things. First of all, to detect if the user is logged in or not. And second, if the user is logged in, we will use this to retrieve the name and profile picture of that user so that we can show it in the user interface. So what we're going to do is let's copy this code, this short code snippet, and add it to a new file under our routes folder called user.js. Go to the routes folder and say user.js, paste our code here. So again, what we're doing, usual, we're building another express router that will only handle a single endpoint. In this case, again, we're mounting the router to /API/Forge prefix, right? So the complete URL that this code will handle will actually be /API/Forge/user/profile. And what we do there, we again instantiate our helper class from common OAuth.js, right? This helper class will help us retrieve token data from the cookie session. And we once again create a new instance of this class from the Forge SDK, user profile API, so that we can call this get user profile. And again, if we were to look at the documentation for the authentication service in Forge, that method call will basically make an HTTP request to this GET request. And it'll return a JSON that may look like this, right? So instead of us having to build, again, the HTTP request from scratch, we're just going to call this method on this Forge SDK class using the internal token, right? And from here, from this internal token, the Forge authentication service will actually be able to retrieve information about us as the logged users. And then what we do, we basically, again, just send a JSON back as a response. And in the JSON, it's basically just an object with two parameters, two properties, name and picture, right? So these we can use in any way we need on the client side. All right, and that's it for this part. This was actually pretty fast. So let's see if we can test this like we did earlier. Okay, so our application is now running, and let's try something. If we go to localhost, again, going to the index page still won't work because, again, we still haven't provided any middleware or any logic or any static file to be returned for just this address, right? But if we go to API Forge and now data management, if we make a request like this, it'll still fail because if you remember, in the data management router, we actually require that some ID parameter be provided as in the URL, right? Otherwise, we respond with 500 error. So let's try that. This should return an error. Let's see if that works. Forge data management. Let's try that one more time. Data management. Yes, okay. So here what we try and do is we try and decode query ID. Okay. So this is a bug in the sample code. I think we had this in the past, but I always forget that it's there. So basically what happens here, we're trying to take this ID query input, which we haven't provided any at this point, and we try and decode it into as a URI component, right? So again, this goes back to what Xiaodong was saying earlier about the URL encoding. When you want to save some information that some string that may contain some unsafe characters like slashes and spaces, you can use this encode URI component and decode URI component to basically replace any of the dangerous characters like the space with something else like $20. I think for example, space is replaced with $20. And then if you took that string and decoded it with this function, it would turn the $20 or percentage sign 20, it will turn it back into a space. But here, since the ID is not defined, the decode URI component actually decodes it into undefined string, which isn't good. So here's what we're going to do. We're going to stop our app and change this code. We're going to say, okay, if not red query ID. So we're going to shift things around, right? So what we're going to say is if there is no ID at all, or if it's empty, an empty string, that's basically when this if condition will result to true. Then we will respond with 500 error, right? Otherwise, we will decode ID and work with it next. So let's try this. Maybe we can put a breakpoint here as well. All right, so let's try it one more time. I'm just going to try and call this request without any ID. And in this case, you see, okay, ID is not available. So we just respond immediately with 500 error. right? So this is the response we got from the server informing us that this request is not correct. Now what I can try and do is say, now let's see if this will work. I think this may actually not work either. And I'll explain why. So I'm going to append this ID equals hash to the URL, but now let's see. It's an empty string. And so yeah, this is something that bit us in the past as well. So this would still return 500 error, and I'll explain why. Hash sign at the end of a URL is actually used to indicate a fragment, meaning a specific section of the HTML document that you may want to navigate to, right? So let me think what would be a good example. I mean, if we go, well, actually, if we go to the LearnForge website, right? Here, if I want to maybe send someone a link to this particular section, I can just click on the title. Oh, but okay, never mind. Here it's using ID, not hash, right? So that was a wrong example. Let me see if I can find some other. Let's see, maybe Stack Overflow. Anyways, I'm not sure if there's again a good example now, but basically when building URLs, right, you always use question mark to separate parameters after your URL. And you can also use hash signs to specify basically an anchor, right? So if I had somewhere an anchor on my HTML page called foo, if I appended hash sign foo to my URL, that would basically point to that specific location in the HTML page, right? And that's basically what's happening here, right? Because we are trying to say that the ID parameter should be set to hash, but since the hash sign is actually at the end, the browser actually thinks that I'm just setting ID to nothing, empty string, and then that I'm trying to append some hash fragment, right? So let's see, there are probably a couple ways to fix this. One thing is I could URL encode the hash sign, or I can maybe, you know what, let me just append one more parameter, and we can call it foo equals bar, right? So we're coming up with another, garbage parameter, but now I think that the hash sign could actually remain there because now it's not at the end of the URL anymore. So let's try that. Let's see. No, it's still just getting. Oh wait, that might be from the earlier. Let's see. Okay, now it's still getting this an empty ID. That's interesting. All right, so what I'm going to do is I'm going to see what the hash sign is encoded in URL. Let's see. So here I just found some website online where I can encode a piece of string. So in this case, I'm just going to take a hash sign, and I would like to see what it looks like encoded. And encoded, it looks like %23. So let's try that. Let's take that and here replace the hash sign with %23, and let's see what will happen. Right. So now we're passing in something else, but it starts with the percentage sign, and the browser will actually be on the server will be smart enough to URL decode this before it hits our code. All right, let's see. And there you go. See, now we've finally been able to push this hash sign to our logic. So now this should not fail. Good. And now since something failed there. Let's see what it was. ID, get internal token. Is it here where it failed? All right, so let's see. I really think it's here. So if we try and get inside the RR helper OAuth function.
Have you logged in? I mean,
I believe so, yes.
okay.
We can try and see if we put a couple of breakpoints into our helper class. Get public, get internal token. Rejection to. This. Let me maybe try and restart this. Okay, so we hit the get internal token helper function. Session expires at. So it says that. What happened? Refresh tokens. Okay, so it's trying to refresh them. Scopes internal. This is okay. Refresh token seems to be correct as well. No? Oh, interesting. So what exactly is failing there? So let me try and wrap this in a try catch. See what's happening here. Down. And then we probably just want to again return early from this URL endpoint handle. Let's stop this. Okay, so let's see what the problem was. The authorization refresh token is expired or invalid. So this might be related to, probably because I have in my cookies, I have a refresh token, but maybe that one was actually generated for different set of credentials, different Forge applications. So let me try and run this one more time. What I'm going to do is,
so when you type this one, is from the same page or different page?
no, I mean, what's possible is that I was running the same demo application on localhost, but with different Forge client ID and different Forge client secret.
Okay. Yeah,
right?
okay. Like
Let me
explain.
try this one more time. Now, if we try and say, okay, get internal token, now it should say, well, there is really no. Okay, let's see. Oh, it's just undefined. So why does this happen? Get internal token, get public token. Let's see. So we check if it's expired. And we see that the session doesn't contain really any expires at. Okay, right. So now this is actually correct because there is no token. So now this should fail. So now what I'll need to do is I'll need to log in again because I cleared my cookies. So what I'm going to do is I'm going to go back to what was the name of the endpoint of URL. Okay. And go back to log in again and to, yeah. So now we've been redirected back. And I think, well, let's see them here. All right, so let's see what happens. Try something. API, Forge, user profile. So now we try and see if there's any token. There is one. All right. Now this should actually, that token should be valid. So we return the internal token. Now, okay, this has the correct value. And now basically the endpoint I'm testing is the one for getting some user information. So here here is where we make a request to the Forge authentication service to request some profile information about a specific user, now myself. and we return the response back. We send the response back to the client as a JSON. So that there it is. Here's my name and profile picture address that eventually the user interface will be able to use to show my name and our profile picture next to the login button, I believe. So that was the problem. I basically had a forge session cookie, but that was actually containing different refresh token for a different application that I was debugging in the past, recently probably. So in this case, I had to clear my cookies and log in again. That was the problem. All right. And that is it for session 3. So now it's your turn. Again, try and follow our steps as well. Add a new router to your server to handle all the data management requests. So retrieving a list of hubs, projects, folders, items, versions. And also add your user information router that will be able to handle the request to /API/user forge/user/profile and return information about the user that we can then use in the web page. All right, and we will see you back here again in roughly 1 hour and 24 minutes to move to the final session, session 4, where we're going to introduce the UI front end with a little bit of HTML, a little bit of CSS, and a little bit of JavaScript, client-side JavaScript to populate the tree view and to load models that you select in the tree. All right. And again, as usual, if you have any questions, let us know in the chat or in the Q&A, and we'll try and answer those as well. All right. Good luck. Okay, we're recording. Hi, everyone. Again, welcome back to the 4th and final session of our webinar today. Now, let's give 1 more minute to see if anybody has any questions. If anyone has run into any problems. I haven't seen any questions in the break, so I'm hoping that, again, everybody has been able to get their server code working and that you have actually been able to test it like I was trying to do at the end of session 3. All right. So assuming nobody has any problems and everybody is all set with the server-side implementation, we can move to the final step, bringing the UI or bringing all the server-side logic together in a little bit of UI front end of our Forge application today. So similar to what we were doing yesterday, we're gonna just use a little bit of HTML markup for our index page with some standard, some basic layout with a nav bar at the top, sidebar with our tree view, and the rest of the real estate used for the Forge viewer. And again, we're gonna, just like yesterday, we're gonna encapsulate all this preview behavior into a separate JavaScript file. That's going to be the Forge tree.js, and all the logic related to the Forge viewer itself, that's going to be encapsulated in a separate JavaScript file. That's going to be the Forge viewer.js. All right, demo time. Let's take a look at our source code here. All right, so our server side is working fine. And we already have our static file serving middleware available and set up. That was here on line 13 in our start.js file, right? So this is, again, the middleware that's going to be responsible for serving any files we place under the public folder to the client when we make a request to something like a CSS file or an HTML file. Okay, now if we take a look, again, if we go back to the Learn Forge website and look at our tutorial here, we're basically moving over to the final step of our View BIM 360 and Fusion Models tutorial, show on viewer. Right? So here, what we're going to do is we're going to just put together one HTML file that's going to be our index page, one CSS file in a CSS subfolder here to define some basic styling for our index page, and then the two JavaScript files with the client-side JavaScript logic for the tree and the viewer. All right. Now, as for the index HTML file, just like yesterday, let's copy the content of that file and use it in our source code. So under the public folder, I'm going to create an index.html file, paste the code here. And again, let's briefly go over what this markup actually does. So in the head element, we're bringing in, again, a couple of third-party dependencies. So with these, we're bringing in jQuery and Bootstrap. So Bootstrap is a popular CSS framework implemented by Twitter. And up to version 4, I believe it still uses jQuery, which is sort of like a helper library that unifies the manipulation with the DOM. DOM is the document object model. That's basically your HTML page, right? So typically, I mean, in the past, if you wanted to manipulate your HTML page in a consistent way, that was kind of difficult because different browsers had different JavaScript APIs or different DOM APIs. So jQuery was trying to unify that so that you could use a single library to manipulate your HTML content in the same way, no matter whether your page was running in Internet Explorer, Chrome, Firefox, or Safari, or any other browser. Now that's not really that needed anymore because the browsers have really standardized. All the modern web APIs have really standardized, but Bootstrap still uses the library, so we're just going to pull it in here as well. So that's Bootstrap and jQuery. We're also loading another third-party library, JS tree. This is a plugin for jQuery that will allow us to build dynamic tree views that you can expand and collapse and browse through. We're going to use that in the sidebar to allow our users to browse through their hubs, projects, folders, items, and versions, and select things to actually load into the viewer. These are the third-party dependencies for that. So the tree has its own JavaScript as well as CSS. Then we're bringing in Forge Viewer dependencies, right? So the Forge Viewer is one of the components of the Forge platform. It is not a web service, but that's a client-side JavaScript library. So Forge Viewer is, again, a simple JavaScript collection of JavaScript classes that you can use on your client side in your web page to initialize one or more instances of a 3D canvas. And that's where you can start loading your 3D models or 2D drawings, and you can customize the viewing of these models. And now pretty heavily, that's something we're going to be looking at tomorrow, how to customize the viewer. And we're also bringing in a little bit of CSS because the Forge Viewer also uses its own bit of styling for the toolbar and panels and the user interface, the Chrome in general. And finally, we're bringing in 3 of our own client-side assets. Main the CSS that we will create eventually under the public folder in a subfolder called CSS, and then the 2 JavaScript files. So we're going to define these a little bit later. Then in the body, we defined the nav bar, right, the header element at the top, where we just provide a link to the Forge developer portal. And then after the nav bar, we basically define one large container with a sidebar and the main content. And for that, we're using all these classes that you see here: container, fluid, fill, row, call, SM4, panel. All these, or most of these classes here, are really coming from the Bootstrap framework, right? So that's how you would typically style your web page to be responsive using the Bootstrap framework, so that when somebody is viewing the page on a smaller form factor like a smartphone, the page can actually respond and restructure its layout so that it can still be easily read, even, let's say, on a smartphone. So we're using all these classes here to define containers and stuff like that. And these call SM4, let me collapse this, right? So at the top level, we just have a container with a single row, and that's coming from the grid system in the Bootstrap framework. And that single row is split into two columns, one occupying 4/12 and the other column occupying 8/12, or you could say occupying 1/3 and 2/3 of the real estate, of the whole width of the page. So the 1/3 that we have on the side, this is where we're going to define the login button and the preview to actually browse through your data in Forge. And the other column is going to be used for the viewer, right? So the remaining 2/3 of the real estate are going to be occupied, used to host the one instance of Forge viewer. We go back to the sidebar again, you'll see that there's going to be a couple of things. There's going to be a small segment HTML area for our user information, where maybe we want to show the name and profile picture of a user if they're logged in. We're going to use a button or a link to an icon to refresh the tree, right, if needed. And we're also going to provide a link to log out if the user is logged in currently. So that on the server side, it will make that, if you remember that sign out URL in our authentication router, that will basically clear the session information. All right, the user hubs, this is basically the div element where we're going to host the preview, right? Showing all the hubs and projects, etc. All right, that's our HTML markup. Now let's take a look at the CSS file. And this is going to be relatively simple, again, very similar to what we used yesterday. So let me just copy the content of main.css and create a CSS file in a subfolder of public. CSS, and the file itself is called main.css. So again, what we're doing here, we're basically just saying the whole HTML page should occupy the full height of the browser window. And this is a custom class that we're using in the HTML with fill to make sure that all the different containers actually fill the entire height as well. But actually, to fill out the 100% of the viewport height minus 100 pixels. That's again some of the reserve we keep at the top for the navbar, right? So we want all the other div containers to occupy almost the entire height of the web browser page, except for the 100 pixels at the top to leave space for the navbar. And then again, a couple more padding margin tweaks. And the user hubs, this is the div that's going to be the 1/3 sidebar on the left, where we're going to keep the preview, right? And if in case the preview gets really large, we don't want it to expand the entire page. So we've specified the overflow, set it to auto. So that basically means that if it overflows, if it gets too large, it's just going to get its own scroll bar that we could then use to scroll just through the preview instead of scrolling the entire page and maybe getting the 3D viewer out of the screen. Yep, and the Forge viewer itself, we're just setting here, making sure that the viewer canvas will occupy the entire width of the remaining real estate. That's it. Nothing fancy going on there really. And then now this is going to be more involved. Forge tree.js. Let's copy this code and again go over it in our project. So I'm going to create another subfolder under public called JS. This is where we're going to keep all our JavaScript, client-side JavaScript code. I'm going to call it forge tree.js and paste the code here. So what we're doing here, again, this dollar syntax is basically coming from jQuery. It's a function that you can use to quickly get a jQuery wrapper for any of your DOM elements, for any HTML elements in your page, right? In this case, calling this dollar function with document basically means getting a jQuery wrapper for the entire HTML document. But we're basically calling this .ready methods to say, okay, when the entire document is ready, do something, right? That's our callback function. And what we say is when the entire document is ready, make a request to our server specifically to this API forge OAuth token. Now, if you remember, that's on our server side, that's the endpoint that's supposed to return the two-legged token for the viewer, right? And if we succeed, which means we use this as a sort of a way to detect if somebody is logged in or not. If this URL, if this request succeeds, that means that somebody is logged in. So what we do is we again use this dollar function to get a jQuery object for the sign out button. And we're going to show it, right? Because if somebody is logged in, we want to allow them to log out. And similarly, we want to allow them to refresh hubs, right? So we use this jQuery construct to get a reference to the refresh hubs icon that's in the UI. We show it as well. And then we prepare some event handlers for these objects, right? So when somebody clicks on the sign out icon, what we do under the hood is we basically redirect the browser to our server again, to the endpoint API forge OAuth sign out. So again, what that does on the server side, you can take a look. If somebody's redirected to API forge OAuth sign out, all we do is we just clear the session object on the request. So using the cookie session middleware, that middleware will basically make sure to clear all the cookies, and then for this user, and then we redirect them back to the index page. So that's what's going to happen if you click the sign out icon. There's also a little trick, which I'm not sure if we need to go into too much detail here, but basically this would only log you out of this particular application, but maybe you want to log out of Autodesk in general, right? Because again, the three-legged authentication workflow, the way it works is that our app redirects you to Autodesk servers. You log in there. So Autodesk may also actually store your login status in your cookies before redirecting you back to our application. So if you really want to log out completely, you can use this little trick to basically redirect you to log you out of Autodesk account control, account management. Yeah, so again, here's a link to the blog post if you want to learn more. I don't think we need to go into more detail at this point. Now for the refresh hubs, when somebody clicks on that refresh hubs icon, what we want to do is, this is basically a way in jQuery to receive a specific instance of a plugin for some HTML element. So we say, okay, get the jQuery object for some div called user hubs and retrieve the JS tree plugin for that element. And here we just call refresh, right? So this is the third-party jQuery plugin for generating tree views. And it provides its own set of methods and APIs you can use, one of them being this refresh method, right? That will basically rebuild the entire tree. All right, and finally, when the document is ready, and if the request to the two-legged token is successful, we're gonna initialize the tree view itself, right, and show the user information. Now, let's see what that means. Prepare user hubs tree. This is again where we're initializing the JS tree plugin that builds the tree view, right? So again, here we use a jQuery syntax to receive the instance of the JS tree plugin. And there's a pretty large configuration object, but I think just to quickly explain what it does, right? You can find this, if you look for documentation for JS tree. This is basically the plugin we're using, right? And you can look at the configuration to see all the different options you can pass to the plugin in your JavaScript code. So we're basically saying, okay, we want to use icons. We want to disable selection of multiple nodes in the tree, for example, right? And here, this is the important part. The data property is basically how we can let the plugin know how we want to populate the tree with data, right? So one way would be to just provide a JSON object that defines all the parent-child chart relationships, right? And the plugin would just show the tree based on that information. But in our case, it's more dynamic, right? We want to be generating the different nodes of the tree based on our server-side logic, where we want to show, let's say, all the hubs. And then when the user expands a particular hub in the tree, we want to make another request to our server to get a list of all projects inside that hub. And then when the user expands a particular project, we want to make another request to our server to get the list of all the folders inside that project. That's basically all contained within these couple lines of code. So we're asking the tree view to always go to this URL, API Forge Data Management. And again, if you remember, that's where we only have this one. That's the only endpoint we handle in this code, the API Forge Data Management. And depending on the ID parameter, we either return list of hubs, list of projects, list of folders, list of items, or versions. So that's what we do there. That's pretty much it. Okay. And there are a couple more options to the plugin. For example, here we say, okay, depending on the type of node, whether it's a hub or a folder or an item or a version, we want to use maybe some custom icon, right? So for example, we use glyph icons, which are provided by Bootstrap, by the CSS framework as well. So we say that if that specific node in the tree represents a version of a document, right, we want to use some glyph icon called time. And a couple more details here. We define sorting of the nodes inside the tree, and we load the tree itself also supports some additional plugins. So we use stuff like here, for example, state is a plugin that allows the tree to store the state of the tree in the browser's cache, right? So it will remember, for example, which node in the tree you expanded, right? So when you reload the page, the tree will actually recover from that state, and it will not start all collapsed, but all the nodes that you had expanded previously, when you reload the page, these nodes will be expanded again, thanks to this extension to the tree. And finally, we're adding an event handler that basically reacts to any event when a node in the tree is clicked. And what we say is whenever a node is clicked, and whenever it's of type either a version or BIM 360 document, we call launch viewer, right? So this is a function that we're going to define in the other client-side JavaScript file. That's going to be the forgeviewer.js. That's going to be our helper function to load a specific model into the viewer, right? So when somebody clicks on some node in the tree and that node happens to represent some model in Forge, not a folder or a project, right? Some actual model, we use this helper function to actually load that model into the viewer. And finally, this was the other helper function, show user, that only shows up if we're logged in, right? We just make a request to our user router, right? That's the API Forge user profile endpoint that returns, if you remember, JSON with just a name and profile image URL, right? So we insert the name as an HTML into an HTML element in our page with the ID user info, and we create an image element with the source actually pointing to the URL of our profile page. So this is just a simple way of showing the name and picture of the currently logged in user. All right. And finally, Forge Viewer. It's going to be, again, let's copy this code and explain and go over what it does. So under the public folder, JS subfolder, we're going to create another file called forgeviewer.js and paste it right here. So basically, this code just defines two functions in the global scope, one called launch viewer, another one called get forge token. Now I'm going to start with the latter. Get forge token is, again, a function, helper function that we're going to use to actually initialize the viewer. And what it does, like I mentioned earlier and also yesterday, right? The viewer is the one exception where in order for the viewer to be able to load your models from Forge, it actually needs to have some sort of a token, right? You cannot just have any Forge viewer on any page access your own data. The viewer also needs to authenticate itself to Forge, just like your server has to. And it needs to do that through access tokens again. That's why on the server side, if you remember, if you look at the authentication router, that's why we have this API/Forge/OAuth/token endpoint that is supposed to provide this two-legged token that is very limited in what it can do, right? This two-legged token is only generated with a single scope called viewables read. That scope only allows this token to read some translated files from Forge, specifically from the model derivative service, and nothing else. So this is the endpoint that our client-side function here is calling. See, API Forge OAuth token. So our helper function here just makes a request to our server to ask it for a two-legged token. And when it's ready, it calls some callback function that may be passed to it with the token and number of seconds during which the token will remain valid. And after that, whoever needs this token will need to make sure to request this token, to call this function again. All right. And the way this is used, you can see that's basically in the launch viewer function. So we're defining an object called options that has a couple of parameters, a couple of properties. env, get access token API. And then we're calling the first function from the Forge viewer JavaScript that we imported in the HTML, and that is this Autodesk.viewing.initializer. That's a global function that is basically responsible for making sure that all the dependencies for the viewer, like images, icons, fonts, are available before we actually initialize the viewer, right? So this accepts a list of additional options. And the second parameter to this initializer function is a callback, something that should be executed when all the dependencies are ready. And what we do is, when all the dependencies are ready, we create a new instance of the viewer itself. And typically, when you're instantiating the viewer, the first parameter should be the DOM element or the HTML element that you want to host the viewer in, right? So Forge viewer, if you remember, is what we defined in our index HTML. This is going to be the div occupying the 2/3 of the real estate, right? And we want this GUI viewer 3D, the Forge viewer instance, to really live inside that div. And then you can provide some additional options like viewer extensions to load. And again, we will be covering viewer extensions in more detail tomorrow. And we start the viewer, right? So this is now where we're finally using the viewer JavaScript APIs. For those, let me refer you to the documentation on the Forge portal. So again, most of these are basically web services that document some kind of endpoints that you can make requests to, but the viewer is slightly different. If you look at the API reference of the viewer component, this is basically a bunch of JavaScript classes, and this documentation API documents all the different methods available on these objects. So for example, if I look at the GUI viewer 3D, this is the object the class we've instantiated in the client-side JavaScript code, right? And we were just calling the start function. So now you can see that you could actually provide some options to the start method as well, but for now, all these are optional, right? And we just initialize the viewer without anything in it just yet. That's what we do here, the viewer.start method. So we initialize the viewer and prepare it for actually later loading a model into it. And then what we do is, when you notice, the launch viewer helper function actually expects a URN. URN is a unique URL safe ID of a model of yours somewhere in Forge. You can obtain the URN in different ways. In our case, we obtain the URN from the data management service, as we're getting the list of versions of a document, right? If you remember, again, we're browsing through hubs, projects, folders, items, versions. Each version points to some model URN in the model derivative service in Forge. So that URN we receive as a first parameter to our helper function. And we basically start loading the manifest for this model from the model derivative service using this Autodesk viewing document.load method. And again, you could refer to the API reference. If you search for the document class, you'll see that there is a method called load. See? So this is, it's like it says, it's a static method to load the manifest of a specific model in Forge. And the first parameter is the ID, that's the URN. And then you need to provide some callback function that should be called in case of success. And then some function that should be that should handle any error situations. So that's what we're doing here, right? We're calling document.load, passing in the URN of our object, and providing two more functions that should be called depending on whether the operation is successful or not. Now, if the manifest is loaded successfully, what we do here is we basically say we get the specific, we call them viewables from the manifest. So for example, if you imagine, if you upload a Revit file to Forge and you ask the Forge model derivative service to extract information from this Revit file, it may actually generate multiple outputs because that Revit file may contain multiple 2D sheets and multiple 3D views. So every one of the sheets and every one of the 3D views would end up being in its own output viewable, right? So there's this one-to-many mapping. One Revit file can generate multiple outputs. So this code basically handles the selection of the viewable output that you want to load. You can see that we also accept a second parameter to the launch viewer function that allows us to choose if there is any specific viewable from that model we want to load. If it's available, we're going to try and find it in the manifest using this find by GUID method. If it's not available, we're simply going to say .get root. That'll get us the root of the manifest, and we're going to use this get default geometry method that will basically return any of the viewables that has been marked as the default output. And finally, we're going to call this viewer.load document node method. So again, we can refer to the documentation if we look at the viewer and say, or actually, I think it's going to be in viewer 3D, load document node. Right, so here, what's required is, first parameter is the manifest itself that we loaded using the document.load method. And the second thing is the actual viewable inside the document manifest that we want to load into the viewer. And by the way, the difference between viewer 3D and GUI viewer 3D is viewer 3D is basically without any UI. It's a headless version of the viewer. It's just the 3D canvas that shows your model, and that's it. It doesn't have any toolbar, any panels or anything like that, right? That's actually added by the GUI viewer, which is a subclass which extends the viewer 3D class, right? But in our case, we do want to see the toolbar and the panels. That's why we're instantiating GUI viewer 3D and not just viewer 3D. And that's it, right? So our launch viewer function, what it'll do every time somebody calls it, is it'll create, it'll create a new instance of the viewer inside the Forge viewer HTML element, right? And it'll start loading new document into it every time somebody calls this launch viewer. And where is this launch viewer function called? It's in the Forge tree file. So whenever this launch viewer function is called, whenever somebody clicks or selects a node in the tree. So let's give it a try. Run our app and see how that goes. And now if I go to localhost without any custom URL, now this should finally work, because this is where the static middleware comes into play. Because if we just ask for localhost colon 3000, we're basically asking for some index page. So the server will try and see if there is maybe any file called index.htm or index.html in our public folder. And it should fine one in this case. All right, and you could see that for a moment, it actually showed Autodesk login, right? And that was because it took the page a while to go back to our server and ask it, oh, is someone with these cookies already logged in? And I was, right? Because I had already been trying the login endpoints earlier in the previous sessions. So I'm already logged in. That's why the UI, the JavaScript code on the client side was able to retrieve the information about my name and some URL to my profile picture. And that's why it now allows me to actually browse through my hubs or the different hubs that I have access to, right? So now here, I think, I'm not sure if I've logged in with my, yeah, I think I've logged in with my personal Gmail account, right? So with that one, I don't really have access to BIM 360 specifically, but I do have access to this hub, which is my Fusion team hub. So I have a couple of projects there, so I can start expanding these, right? So these are my projects that I have access to under a Fusion team. And if I expand one of these projects, I make a request, expanding this folder will basically make a request to our data management router in our Node.js server, asking it, what's the list of all the top level folders of this project? Right, so it's going to say, well, there's just one folder called demo project. And if I expand it, and again, we can try that here. Let me clear the network tab. And now if I, let's say, I don't know, let's say I try and expand this file here that's sitting somewhere in Fusion team called wally.f3d. I hit the expand. Here you'll see that the client-side JavaScript actually made a request to this API Forge data management, and here the ID, right? If you remember, this is where we were, that's what we were discussing earlier, where in the ID we can encode a specific information like, okay, we want to list all projects inside a hub, or all folders inside a project, or all versions of a specific model, let's say, right? So we asked the server to tell us what all the versions are of this specific F3D file. And the response, the server responded that there is just a single version, V1, that was created in, on March 17th, 2021. And it's this URN, right? Again, this is the URL safe URN of a specific model in Forge. So maybe one thing to explain here is this is actually using base 64 encoding. So this result is a base 64 encoded string from some object ID in Forge. And the viewer understands this URN, right? So when we call the launch viewer function, we can maybe put a breakpoint in our client-side JavaScript code in launch view in the launch viewer function, right? So when I, let's say, click this V1 version of my Wally F3D file, right? You can see that now our launch viewer function has been called and is asking us to load this specific model with this URN and no special viewable for this F3D file, right? So we just want to load the default. So what we're going to do is we're going to create a new instance of the viewer, right? And you can see now this gray area that's already the viewer taking its space. We want to initialize an empty viewer, and then we're going to try and load the document for this URN. Right? So let me put a breakpoint into both of these. So we catch both situations, if the document loading is successful or when it fails. I'll let it play. All right, so the document has been loaded successfully. You can actually see it in this first parameter to the function. This is the manifest generated by the model derivative service that defines what different viewables have been extracted for this particular F3D file, right? So we could even try and navigate it ourselves. So we see that, The conversion status is success, and it's complete 100%. And to check the different children that have been extracted, we see that we can probably see what's been extracted here. And, we've been able to extract some metadata. So that could be, let's see, this could be probably design description type of resource that it's also available, provided by the model delivery service. But I'm trying to see if there is one that probably is more relevant. I think that's going to be, oh, this is a folder. Okay. This is a folder that includes additional children. Here is an animation for an S3D file. So, these are basically all the different outputs, different types of information that the model derivative service extracted from this S3D file. And I think this one might be the one I'm looking for. Yes. So this is basically, this output is a geometry. So that's a 3D file that we can load into the viewer, right? So when we call this doc.getRoot.get default geometry, it will actually go through all these outputs until it finds like the 3D geometry or 2D drawing default viewable. And let's see what happens there. We found a single viewable, right? So we see it's the viewable with ID 4. It has a couple more children underneath it, but this is basically the object from the entire potentially complex manifest we want to start loading into the viewer. So we pass in the original manifest and this viewable into the viewer load document mode method, and that'll basically kick off the loading of the model into the viewer. And here's our Wally. And yeah, that's it. Now again, if we hit this sign out button, we should hit the sign out endpoint in our server. You can try that here, right? So if I try and hit the sign out, there we go. See, so now what we do is we just clear the session object, which now still contains the cached tokens and expiration times, right? So we just set it to null, so the session object is no more. And now, after redirecting the user back to the index page, the cookie session middleware will basically clear all our cookies. So you can take a look here, the application, we still have some cookies, right? There's probably going to be the fork session, right? That's still the cookies that we had cached from earlier. But now when we get redirected to the index page, now if we take a look at localhost, you can see that the fork session is gone, right? Because it's been basically removed by the cookie session middleware. So we've been effectively logged out because all the cached information about the tokens is gone now. So I can log in by hitting the sign in button again. That will redirect me, see, to the accounts.autodesk.com website where I can sign in, and I can, I'm redirected back to my application with a temporary code. The server will exchange the temporary code for access token and once again store it in my cookies encrypted so that nobody else could potentially steal this. And that is it for our Forge application today. So now, again, try and see if you can follow my steps, follow the steps in the tutorial, and to build the standard basic HTML layout with a little bit of styling, and add the 2 JavaScript files for the client-side logic. One implementing the behavior of the tree, and one implementing the behavior of the viewer. And yes, that is it. Now, if there are any questions, just like yesterday, I will stick around for roughly 30 minutes. So if you run into any problems, please let me know. I'll try and answer your questions. Otherwise, I'll see you tomorrow on Wednesday, where we have a shared webinar for both groups that have been working with Node.js or .NET, right? Because tomorrow we're going to be looking at the viewer, how to customize it, how to read data out of your models using the viewer APIs to build sort of dashboarding applications. So for that, you don't really need Node.js or .NET specific backends. It's up to you which one you use, because tomorrow in the webinar we're just going to be modifying the client-side aspects of your application, and I'll be teaching that class for the EMEA group as well. All right. So with that, and again here, yeah, if you think of some question after we close this webinar today, you can either wait for tomorrow or you can reach to us through some of our official support channels, one of them being Stack Overflow. We're trying to be very active there. So if you submit any questions on Stack Overflow with one of these tags, we're going to get notified in our ticketing system, and we're going to try and get back to you as soon as possible. Or if you want to discuss something more private, something more specific to your project, you're free to reach to us through some other channels as well. For example, if you go to the Forge portal and look for Get Help under Support, there's basically a way for you to submit a question through an email as well. And that will also go into our ticketing system so that we can get notified and get back to you when we have a chance. All right. So with that, thank you for stopping by. Thank you for joining us today. Thank you, Deepali and Xiaodong, for helping me out. And yeah, like I said, I'll stick around for roughly half an hour. So if you have any questions, keep them coming. And yeah, and I'm hoping I'll see you all tomorrow as well.
Thank you, Petr.
Thank you.